Welcome everybody to episode 5 of Code and Coffee. Today I'm going to be demonstrating how to model an existing newly conditioned ADU. So those of you who have been on one of these live streams before, welcome again. And those of you who are new to Code and Coffee, come on in, grab yourself a cup of coffee, and we're going to be demonstrating how to model certain project types here in EnergyPro. So I wanted to say thank you to our sponsors, EnergyCode ACE. If you're not familiar with EnergyCode ACE, please go to the EnergyCode ACE website after the show, obviously, and register or sign up using your email address. That way you'll get notifications on when new training opportunities are available, new resources, fact sheets, trigger sheets, various offerings there, and new training. So we do broadcast our training opportunities quite often, so that's how most of you likely got the notification about today's Code and Coffee episode. So thank you again to EnergyCode ACE for this. I'm going to go to our introduction page and just give a brief rundown on our project here. So this may be new to some of you, so just stay tuned, and if you have any questions, feel free to chat those questions in the chat box. I try to keep up on all those, but sometimes, for example, our last episode, we had quite a few questions, and I wasn't able to get to all of them, but we will be addressing some of those questions live while I'm doing the demonstration. This is part 2 of our ADU, our accessory dwelling unit series. So what we're trying to do is give a little bit of an insight on what some new clarifications from the Energy Commission on how to treat these very special dwelling units, residential dwelling units. So I'm going to be going through some of these measures here today. A little bit about our project. Our project is a small accessory dwelling unit that was an existing garage that my client here wants to convert to an ADU. So it is attached to the existing dwelling, so this is slightly different than the previous project. We're going to be going through doing a project assessment, reviewing the plans, doing our takeoffs, modeling the project in EnergyPro, which is the current version 7.2.3 is our current version. There is a new version coming out. I was not able to get the latest and greatest that had the ability to model the wall extensions, but I will be covering that. That version of EnergyPro will be available soon. So, all right, without further ado, let's jump into our project assessment here. We have here is our existing garage being converted to an ADU. Here's our existing dwelling, and in conjunction with this addition, they're going to be adding a new garage to replace their old garage. Here's a little bit better picture of what's going on. So you can see on the left, we've got a new ADU within the existing garage, and then here's the new garage on the right hand side. So if we look at that in plan view, this is what we're dealing with. We've got an existing structure here. We'll do a takeoff and figure out what the area of that existing structure is, as well as here's our new addition here. So let's dive into this, and we're going to start our takeoff, and I'm going to go to my over-the-shoulder camera here for just a second and give you a little peek of what I'm looking at here on my screen. So okay, I'll just move the camera over there like that. So okay, let's start with our takeoff. So if we're dealing with an existing attached dwelling, what we're going to need to do is identify what the existing square footage is. So those of you not familiar with Bluebeam, I'm going to be using the area tool here and zooming in and dealing with figuring out what my area is on an existing house. So you can see I'm just snapping to endpoints here. This is going to give me an area. I've already calibrated this particular PDF file, so I don't need to worry too much about doing that. Those of you who are new to Bluebeam, just keep in mind that this is a PDF viewer. It is a paid subscription to get this. You can do a very similar process by using the Adobe Adobe Viewer, the Adobe product. It would be a very similar product that you could do this takeoff with. All right, I'm just going to do an area tool perimeter around this building and determine what my square footage is. So just about done here. All right, thank you guys for your patience this morning with the technical difficulties. All right, so we've got about 1570 square feet for our existing building here. And if you're not familiar, I do my takeoffs just on an 8.5 by 11 piece of quad paper. Some people like to do it within the PDF document. That way they've got a copy of it and can access that at any time and save it. But for today's purposes, we're just going to write it down. Okay, let's go around our ADU and get our areas here. Let's see, I'm going to switch to the Bluebeam screen. That way you guys can follow. All right. Some of you may be experiencing some choppiness on your display. If you are, can you hit us up in the chat window and let us know what kind of quality you're getting through the YouTube channel? I'd like to make sure that we're providing the best quality possible here. Okay. All right, so the area of our ADU, I'm going to round this off. It says 552.7. I'm going to round that to 553. So we've got 553 square feet on our addition ADU. We've got, let's take a look at our elevations so that we can make sure that we know what our heights are here. So I don't have a cross section on this, but I can estimate my my building height. Oops. Here for my elevations, I believe we're at 9 feet. Yep. So let's go with a 9-foot plate on this. So okay. All right. Well, again, I apologize for the quality of the video, but we'll do our best here to make sure that you get some good information. So what I'm doing is I'm at the front wall here. So our orientation of this house, the front is facing 180 degrees south. So what I want to do is gather some information, some wall areas. The front is 20 foot 10, so 20.8333, 9 times. So we have about 188 square feet of front wall. Let's gather those window dimensions. We have a 4 foot wide by 2 foot 8 high window. So That's about 10.7 square feet for the right window, 10.7 for the left. Let's move our way around the left-hand wall. If you're familiar, if you watch some of our episodes, the way I like to do my takeoffs is start with the front wall and go clockwise. The same goes with windows. So start with the front right wall, front right window, and work my way clockwise. That way I always have the information I need at hand. So our left wall here is 27.5 feet, and that's 9 foot high. So we have 240, let's call it 248 square feet, or 247.5. We've got a 3068 door here. Let's take a look and see if that door is glazed door or a solid door. So it looks like we've got some glazing in the top of that door here. So what I want to do is get an area of that glazing. So what we want is the area of the glazing. Because this is less than half of the door in area, we only look at the amount of glazing plus 2 inches around that perimeter. So that's going to give me about 5.2 square feet of window plus the door. So if we have 20 square feet of door, subtract that 5.2, so we should have a remainder of about 14.8 square feet of door area. So let's go ahead and go back to our floor plan here. So I'm just capturing this information on my worksheet here. Our next window is a 4036. That's 14 square feet, and the window next to that is a 4020, so we have 8 square feet. Take a look at this here. Now, we've got some back wall area, so just keep an eye out for areas in the plan that may not be dimensioned. So in this case, we've got about a 3-foot wall here and a 2-foot wall on this side. So we've got 5 feet of rear wall, which is facing north. So we've got 45 square feet of wall that we need to account for. But as you can see, there are no windows or doors in that, so we don't need any openings. Working our way around to the right-hand side, we've got basically the same amount of area, so 27.5, actually slightly less, 4 inches less. You can see that offset there. I'm measuring to the outside face of the existing house, or the inside face of the ADU on this side. So we've got 27 27.1667 times, so I get about 244 square feet on the right wall, and we do have a few windows here. It looks like they're infilling an existing window there, so we're not going to count that. We need to account for these 2 windows, these 3016. So those are 4.5 square feet apiece. All right, so we've got our wall takeoffs, our door and window takeoffs. Keep in mind that this is a slab on grade, so we're also going to need to get a perimeter around this. So we've got known dimensions here. We can just add this up as opposed to doing a perimeter dimension using the linear tool here. So we've got 27.5 on the left, 20.83 on the front, 27.2 on the right, and we got 5 feet on the back. I got about 80.5 feet linear footage of slab edge. So that should wrap up all of our takeoffs. So let's go ahead and jump to our EnergyPro screen. And I'm going to move this over here because my screens aren't working right. How's the chat window working? Is that back up and running? Okay. Well, what I'm going to do, because I had to. Okay. Great. Stand by. Oh, I see what's going on. Okay. Well, keep me posted on any chats. Those of you who are listening in, I'm talking to my tech team here, so just keep me posted of any chats that are going on that I need to answer. So any questions. So. All right, this is our EnergyPro screen. I'm going to do this from scratch. I'm not going to use the wizard this time. So what we've got here is just our building level tab. So started a brand new project. I'm going to call this existing attached ADU project. So our front orientation is 180 degrees. We've got natural gas. Now, for those of you looking on about this project here, the project is in Santa Clara, which is climate zone 4. I did a little bit of pre-work with this and went to Zillow, figured out how many bedrooms were existing in this, so we'll need to enter that information, here. So we changed the building type to an addition, which gives us an opportunity to input this existing information. So 1570 square feet. The number of existing bedrooms I got from Zillow was a 4-bedroom house. So we're going to go with that for right now. Our climate zone, since this is Santa Clara, let me zoom down here and see if I can find it here. Santa Clara. See, there we go. We'll use there it is, Santa Clara University, climate zone 4. Good. Nothing else to fill out here, so we've got our general information input. I'm going to add a plant, which is our hot water heater. I'm going to add an HVAC system, and my technique here is I like to leave those blank until I get my zones built, my dwelling built. So this zone, new zone here, is, I'm just going to call this ADU. So it is a single family occupancy. Our building story is going to be first floor. Our ceiling height is 9 feet. Our elevation above grade, since it's a slab, is 8 inches or 0.7. Floor to floor height. Just keep in mind that floor to floor height needs to be more than your ceiling height. So in this case, I'm going to add, make that 10 feet. Window head height, 6'8". That's pretty standard there. So just hit OK. At this time, I like to click on the dwelling tab. I'm not a big fan of keeping the appliances on. Just keep in mind that it doesn't matter whether the appliances are on or off. Your standard design and your proposed design for appliance energy use is going to be the same. So I just prefer to turn it off. I want to change my number of bedrooms to 1. In this case, we've got a single bedroom accessory dwelling unit. All right. Good. Everybody following along okay? Any new chats going on, guys? Okay. Great. Sounds like everybody can hear me fine too. So I right-clicked on the zone. I'm going to add a room to this. I'm going to just call this room the ADU. We know our square footage is 553 square feet. All right, nothing else to fill out there. I'm going to go ahead and drop in some opaque surfaces. So I've got 4 exterior walls. I'm just going to add all 4 of those exterior walls here. I know I have a roof. I'm going to come down here and add a roof. I know I have a slab. slab on grade. And if you follow it along, you'll notice that there is some existing interior wall here, and we can actually add this in our addition. So that existing wall, I'm going to be using a default value for that wall assembly, but just keep in mind that wall is going to be adjacent to an existing dwelling. We're not going to define what that existing dwelling is in a zone. We're just going to tell EnergyPro to use that feature to make it adjacent to an existing dwelling. So I'm going to drop in an interior surface there, and we'll do that takeoff here in just a minute when we get to it. All right, so our first wall is going to be our front wall. And we've got our area. Let me go to my over the shoulder view for you guys and show you what I've got going on here. So this is my takeoff. You can see I've got my front wall in the same orientation as it appears on the plan. Left wall, rear wall, and right wall. And then we're going to have some wall area that's adjacent to our existing space. So that's how I do it. Very simple. You may have a different process that works better than this, but this has worked well for me for years. So, all right, back to our EnergyPro screen. We're going to enter our first wall area of 188 square feet. It is a new wall, so I want to clarify that even though this is an existing structure, it's an existing unconditioned structure, and it's going to be newly conditioned ADU. All of our opaque surfaces, all of our windows, all of our doors are going to be new surfaces. They're not existing or altered surfaces. Keep in mind what the definition of an addition is. Anything that adds conditioned floor area and volume. In this case, we're doing that. All these surfaces are going to be considered brand new surfaces, with the exception of that interior surface between the new ADU and that existing garage. So when the new version of EnergyPro is available, we'll be able to click this wall extension feature here and define that this wall is an existing or it's being extended, an extension of existing wall. If you're familiar with the Energy Commission's blueprint that came out, there is a workaround, and today we're going to be also doing that workaround. We're going to be adding the prescriptive wall workaround. So what we need to do is select this. Now, if you go to table 140.3a, the prescriptive requirement for climate zone 4 is a wall with a U factor of 0.051. So we've got that here. This is actually modeled as a R19 2x6 with R5 continuous. It could be a R21 with R4 continuous. Both get you a 0.051 U factor. But the point here is we want to label it prescriptive wall for right now. When the new version of EnergyPro, or if you're using CBEC Res and already have access to that wall extension feature, you're welcome to use that now. So just keep in mind, as soon as the new version of EnergyPro is available, don't use this workaround any longer, because what's going to happen is it's going to confuse our building departments, and we want to be as accurate and as up to date as possible. So our orientation for that front wall is 180 degrees. I'm going to go ahead and lay out all the opaque surfaces first, and then we'll come back and do the windows here. So we're doing our clockwise routine here. So our left wall is 248 square feet. It is a new wall. It has the prescriptive wall, the 0.051 U factor wall there. The orientation of that, since we're going clockwise from 180, is 270 degrees. That wall faces west. Our rear wall, if you remember, we had a little bit of area there on the rear, those two little pop out. So we had 45 square feet of new wall. We're going to add that as the prescriptive wall as well. And the orientation is 0 since we're going clockwise 90 degrees. That's facing north, and our last wall is going to be the right wall. Now you have a different naming convention for these. You might call the front wall the south wall, and that's perfectly acceptable. It just depends on how you like to name those services. Those are user defined. You can name them anything you want, but they've got to be unique and as definitive as possible. So our orientation is 90 degrees on that wall. Let's do our roof here. Now our roof, we need to meet our prescriptive requirement. In this case, let me go to the reference ACE, and I wanted to bring up table 150.1a just to point out what's going on here. So we're climate zone 4. As you can see, climate zone 4 has a requirement for high performance attic. So keep in mind, if we do not include a high performance attic in this situation, we're going to incur an energy penalty. So and in this case, since they're doing asphalt shingle, that's a no airspace situation. So what we're held to is an R38 ceiling insulation, R18 below roof deck insulation. Now we could choose another strategy for doing this, meaning that we could do a option A, which is above roof deck insulation, or if we were doing a conventional HVAC system, we could configure that with the ducts and conditioned space. But in this case, the client information said they wanted to use a ductless mini split system, therefore we're not going to be able to use that option C. So okay, moving right along. Let's configure our high performance attic option B. So in this case, we should have an R38. I've got one here, but I want to walk you through how to create this from scratch. So I'm going to use an existing assembly to start with. I'm going to call it R38 plus R18 roof attic. This is a vented attic. What we're proposing to do is put R38 in the ceiling, which is already indicated here. These are 2x4 ceiling joists at 24 inches on center. We're going to add an R18 below the roof deck. Now that's the prescriptive requirement. I could technically add something less, maybe an R13 or an R15 in there if that's what the client was more comfortable with, and I could get it to comply. That's great. I could also add that as R19. You know, most of you know that you can't buy an R18 bat, and nominally a 5.5 inch cavity would fit R19 in there. So I'm going to just go with the prescriptive requirement since that's the way I labeled it, and hit OK. The orientation of this attic roof is relative to the front of the house, so 180 degrees. Let's take a look at our roof slope. I can't remember what that was. So we had a question in the chat. Somebody was asking if we went with above roof deck insulation, would they need new roofing? Yes, they would. Now, keep in mind, because this is an addition, that existing roof is considered as a new surface. Therefore, the roofing is, as far as the model is concerned, looked at as a new roof. If that existing roof wasn't a cool roof, we couldn't claim the cool roof credit. You know, either way you go, this, as far as your inputs into the software, that's going to be considered a new roof. So it doesn't look like we have a slope on there. It looks about a 6 and 12, but just in case you don't know how to determine that, it's amount of rise per run. So if we had a 12-inch run, how many inches of rise? Or in this case, if we had a 12-foot run, it's a little bit easier to see. I can actually go through and measure that and get a good idea of what our pitch is. So it looks like it's a 6 and 12 pitch. You know, again, I wasn't super accurate there, but I'm pretty confident that if we input a 6 and 12 pitch, we're pretty darn close here. Just switch back to EnergyPro, so we're going to input that there. Now this is important so that the software realizes that there's enough room up there to put ceiling insulation and below roof deck insulation there. So hopefully my answer to the question about above roof deck insulation and new roofing was on the spot there. If not, please let me know in the chat window. We can address that. Okay, so we've got our walls, we got our roof. Let's enter our slab information. We've got 553 square feet of slab area. That's slab on grade. It's not a heated slab, so I'm going to leave the default alone. We've got 80.5 linear feet of perimeter, and I'm going to leave this surface condition as 20% exposed. That's a default value. That's assuming that 80%, let's see, 80% of that slab is covered with something. So that would be the worst case scenario. If you knew it was all exposed, you could use the exposed feature there. Basically, you're gaining a little bit of thermal mass credit, but not a whole lot there. Let's address this interior surface. Wall to existing house. Okay, so back to Bluebeam, back to our set of plans here. We've got this little bit of wall area. Hopefully the display isn't as choppy as it was. Seems like it's running a little bit smoother. I'm going to take a dimension here. I'm thinking that if we subtract it, so it's 15 foot 10 there. So we'll call that 15.8333 9 times. Let's call it round numbers, 143 square feet. So we'll come back to EnergyPro and call this area as 143 square feet. Now, this surface is existing, and it's all right to call it existing. Really, all you're doing is defining that that wall does not have any solar gains. It's adjacent to a different dwelling unit. So basically, what we want to do is input that surface as a default. This house was built prior to 1978, so I'm just going to use the default wall. I like to sort these by type. That way I don't select the wrong one. If you selected a roof feature by mistake or a floor feature by mistake, the software is going to have a fit. So it's going to say that doesn't make sense. You defined a wall and you put a roof assembly on it. So make sure that those are accurate. And the easiest way to do that is just click the sorry. Okay. All right. I've got a question. Let me look here. We've got a question in the chat here. So Elizabeth says, if the walls and attic are high performance assemblies notated on the reports, does the building department expect that type of construction in the field? Are notes added to the report? That's a really good question, Elizabeth. In the answer to the wall question is yes. The answer to the roof question is no. That if we're expecting to do a high performance attic in the ADU, then the plan checker and building inspector should expect to see that high performance attic in the field. Now, we're currently using the workaround for ADUs. The Energy Commission gave clarification that if we model the walls as prescriptive walls and then we add notes to the project, and you'll see that I have some notes that I'm going to be adding to this that will explain to the plan checker. I also personally, in the past, have taken the practice of doing a letter, writing a letter to them explaining the workaround. I actually attach the CEC blueprint and the CBEC Res FAQ explaining the workaround. So far, I haven't had any issues with it. So hopefully that answers your question, Beth. And then your second question is, what is the value of adding an interior wall connected to the existing dwelling unit? Just adding that surface there. That's all that we're doing. We're just indicating that that surface is actually there. So let's see, the chat box issue here. Give me just a second here. Let me chat window. We'll call it what I'm trying to do is get that chat window within our parameters there. How's that? All right. Good. Yeah. I may have messed things up with the chat window that now we can't even see it. So we'll see if that comes back live. But I've got ears and eyes on the YouTube chat, so I can monitor those as well. So okay, back to gosh, we're plagued with technical difficulties today, so which is kind of a bummer. And I've just locked up my give me just a second. I just locked up EnergyPro. Oh, this is a fun one. Yeah. I don't know if you guys are following along here, but I apologize for the technical difficulties. This is probably one of the most challenging Code and Coffee so far. So let me, gosh darn it. I may have to, yeah, it's frozen. Yeah, EnergyPro is frozen right now, and I do not know why. So, give me just a second here. Well, nothing like adding a little bit of interest to our YouTube video. So, what I'm going to do is I'm going to bring up the other version of this just so we don't get delayed. I have a solution worked out here. So as you can see, I've added the existing wall to this. I'm going to change this to be default prior to 78 wall. And then I'm going to come through and just highlight the windows that I entered here. So if you're not familiar with how to enter a window, you can just right click on the surface, add a window. You can copy and paste windows. So let's just go through our window setup. We've got two windows that are 10.7 square feet apiece. We've got some, let's see, that was 5.2 square feet of window that was in that door. Now, I like to change this so that that door is actually representing a default value. So I've taken the double non-metal clear default and copied it. I changed it to a door. So we're looking at a manufactured product using a default U factor and SHGC. You've got to come down here in the fenestration properties and change this to represent the fenestration type. In this case, it's a door. There are 2 panes and it's operable. So that's the configuration for that particular window. All the other windows, I'm going to be using the prescriptive fenestration requirements, which are 0.32 U factor and 0.25 SHGC. So we know we've got 14.8 square feet of door. We've got 2 more windows in there. We've got a 14 square foot window on the left wall and an 8 square foot window. The rear wall didn't have any windows, but we work our way around to the right wall. We've got 2 4.5 square feet windows on the right wall. So at this point, we've got all of our opaque surfaces. We've got our fenestration put in. Fairly confident that everything looks accurate there. Let's go ahead and address our HVAC system. Now, in this case, our client wanted to install a ductless mini split system. So I had a ductless mini split system in my library here. The client had given me some specs, which I don't have in front of me right now, but you can go to the AHRI website and download the rated efficiencies. In this case, the system type is a split direct expansion system. It is a heat pump, so the heating type is heat pump. Total output, it's a 2-ton unit, so our total output for this one on BTUs was 26,000 BTUs. Now the 17-degree output for this particular unit that I modeled was 16,600 BTUs. Let me switch. Yeah, I'll just go back to our Bluebeam screen. So there's no electrical power. Supply temp is a default, but my efficiency was an 11 HSPF. Now this is a pretty efficient heat pump here. I think the mandatory minimum for a split system is a 8.2 HSPF. So we're well above that. Oops, let me go to our cooling tab. For cooling, now I'm modeling this exactly the way it's rated. So just understand that within the software is going to downrate this cooling system efficiency based on a standard split AC system with ducts in the attic, regardless of how I model it. So my practice is model the HVAC system as accurately as I can, and don't worry about what the software is doing in the background, because effectively it's going to look at this as a 14 SEER 11.7 EER unit, assuming ducts in the attic. But you don't have to model that. That's something that the software does automatically. So in this case, my total output cooling capacity, round numbers, 24,000 BTUs or 2 tons. The sensible load on that, my rule of thumb is about 70%, which is 16.8. The supply temp, high reset, low reset, all that stuff is defaults. My efficiency on this one, again, pretty high SEER and EER. It's 21 SEER, 12.5 EER. Just understand, I'm not going to get credit for that at all. So the other thing I need to do to model that ductless mini split is to come in here and define that heating distribution is ductless, cooling distribution is ductless. You'll see that the duct insulation value grays out and disappears. So But the way I input this information, I've just defined that it's a heat pump and it's ductless. The software knows that this is a ductless mini split system, therefore automatically deducts the efficiency for the cooling. But I do get to claim the efficiency for the heating, which in this case it's better than nothing. I don't have any ventilation cooling installed in this. I'm not claiming any HERS measures like refrigerant charge verification. But if you were, just understand that refrigerant charge verification may be a prescriptive requirement. Don't remember offhand. Climate Zone 4. Anybody know offhand? I'm looking here. Not required. Climate Zone 4. So we're not incurring any energy penalties for not putting a refrigerant charge verification there. So, okay, our water heater. This water heater happens to be a high efficiency gas tankless water heater. So our energy factor for this is a 0.95. The volume is 0 gallons. Now in some cases you might have 0.2, 0.5 gallons. Just model it as if you have specifications. Model it according to the AHRI rating on that. So if you don't have specifications, you can model this as 0 gallons. One thing I like to bring to some consultants' attention, you may have run across this. If your input rating is 200,000 BTUs or less than 200,000 BTUs, it's considered a residential style or small tankless water heater. And that's fine. That's perfectly acceptable. It runs the analysis, shows compliance. The installer can put in whatever they want as long as the BTU input rating is less than 200,000 BTUs and the energy factor meets or exceeds that value. Technically, that's an acceptable water heater. But if the project is registered with a HERS provider and you go to complete the installation certificate, the installation certificate makes you put in a water heater that is within, I think, 10 or 15% of the BTU input rating. So if you put 199,900 and they actually installed one that was 150,000, technically you're going to need to update that CF1R, re-upload it to the registry so that the installer can actually register an accurate CF1R. So some of you may have run into that situation. Let's see. Olivier had a question. Is your wall property window hidden somewhere? Not sure if I understand the question, Olivier. Is your wall property window hidden somewhere? Oh, you might be referring to when I open any of these configuration. Let's say I open a wall. It pops up off screen and I have to drag it onto the screen. So if that's what you're referring to, yes, it does. It's kind of hidden, but it pops up on a different screen. So, all right, back to our water heater. Let's take a look at our anything else. So this is a new water heater. It's a 0.95 energy factor. I'm pretty confident here that this is representing what the client wants. We don't have any distribution credits. I'm using the standard distribution, which is, according to the plumbing code, all pipes insulated. In this case, all accessible plumbing hot water pipes would be fully insulated. So, all right. In this case, I've ran the analysis here for our suggested response, and I came out with a compliance margin of 1.38. I'm going to blow this up a little bit so you guys can see it a little bit better. Oops, went too far. So you can see our standard design was 44.55. Our proposed design was just under that by a margin of 1.38, which gave us a percent improvement of about 3.1%. So that's great. I'm happy. Just want to point out that This is displaying that this is a newly constructed additional loan project, which that's what we're doing. It's a new ADU unit. Our conditioned floor area is 553, which is equal to a slab area and our addition area. So all these columns are representing what we're trying to do. It is a single zone, single story, natural gas available, rotated 180 degrees. So let's just check our special features here. This is indicating that we have insulation below roof deck. That's good. We don't have any HERS verifications. Now keep in mind that this is an addition. It's less than 1,000 square feet. So one, we have not triggered indoor air quality requirements, right? So that would require, if we were above 1,000 square feet, we would trigger indoor air quality, bare minimum exhaust fan. That would require us to register with a HERS provider. Since we're doing a ductless mini split system, we don't have any duct leakage. We don't have airflow of fan advocacy, so we don't have any HERS verifications. This is a good example of a project that would comply without registering the compliance documentation. So you can see there's no watermark across that. So bonus, we've got a project here that we don't have to register. Save the client a little bit of time, a little bit of money there. So now I do like to clarify that the Energy Commission's recommendation is that indoor air quality fans be installed, but technically, according to the code, it does not trigger it. So it's always a good recommendation, from the energy consultant standpoint, to recommend that they address indoor air quality, because it is its own dwelling unit. It is technically not in communication with that existing house that may already have an exhaust fan. So great recommendation. So our building features, this is showing 5 bedrooms. Now keep in mind, we have an existing house that this is being added onto. So it's representing the total number of bedrooms in that particular building as a whole. So it does not represent the number of bedrooms for the ADU. Average ceiling height is right. These are our opaque surfaces. We could go through our takeoffs and verify all this, but it looks good. We got the front wall at 180 degrees and we've gone clockwise. Our existing wall is represented there. So now it's up to you. I know Beth brought this up. It doesn't necessarily need to be identified. It's up to you. I have a preference of identifying all the surfaces that are associated with that dwelling unit, but I haven't run the analysis without that wall. I highly doubt there's going to be a large difference in the compliance margin, if any. All right, here's our attic space. So we don't have a cool roof, we don't have a radiant barrier. We got a 6 1/12 pitch. All of our windows, we could compare this to our takeoff. We do have one window with default values. If you remember, that's those 3 little windows in the door on the left wall that was facing west. Opaque doors, we've got that listed there. Here are all of our opaque surfaces. So here's our attic roof. So we're showing below roof deck insulation, R18 below roof deck insulation. Why is that showing a total R19 in that cavity? Did I change something? Should have said R38. Oh wait, here we go. That's our below roof deck insulation, R19. Our ceiling insulation, R38. Our prescriptive wall. So you see this one here, 2x6, 16 on center, R19. Now, I've gone ahead and added a comment to the plan checker down here. You can see that in the project notes. Plans examiner, please review the following note to clarify what is to be installed concerning wall insulation. This project consists of converting an existing, I should say detached, garage into a newly conditioned attached ADU. So, and I'm explaining what I'm doing here, that I modeled a prescriptive wall here, but I'm only intending to install R15 in that cavity based on the exception in section 150.2. You can look that up. I've also given the links to the blueprint number 122, as well as the CBEC Res FAQ dated April 10th, 2018. Now, keep in mind that that workaround is only good until the software is available. I believe CBEC Res already has the capability of demonstrating wall extensions within the software. So if you're using CBEC Res, don't use the workaround. Model the wall as a wall extension and click the wall extension button, or configure it as an extended wall. And those are good for all of the exterior walls for an ADU. Now, that's not true for an addition to an existing house. If you're adding on more square footage to an existing house, you can only use that wall extension feature for the walls that are truly wall extension. But for an ADU, use the wall extensions for all of your exterior walls. So, and I believe EnergyPro shortly is going to have that feature available on their website for download. So slab floors, we're good there. 553 square feet. Perimeter, no perimeter insulation, no QII. Our water heater information here, 0.95 energy factor, 199,000 BTU water heater. Here's our heat pump here. Here's our efficiencies. Again, it's displaying actual efficiencies. Here's our heating efficiency, our cooling efficiency. This should match what the specs are, but just understand that the software is devaluing that cooling system automatically behind the scenes. You don't have to tell the software the 14 SEER and 1170 ER. Just model it the way the specs are and move on. So good, and it's showing that we'd have 0 indoor quality requirements here. So hopefully this makes sense to everybody. Is there any follow-up questions before we wrap today's session up? Well, while you may be typing some questions, I just want to thank you guys for hanging in there. We did have some technical difficulties today, and I truly apologize. I hope that the experience was as good as possible. You know, this is a fairly new show. We're on episode 5, and we're encountering little bugs here and there. But if you like this show, please hit the like button, the thumbs up button. That's always nice. Lets us know that you appreciate that. And we are increasing the number of subscribers. So if you haven't already done so, hit that subscribe button. That way you'll get notified when we have new content up there. I am planning to do some very short videos. They won't be a live video. They'll just be recorded. Various tips and tricks for modeling. Expect to see those probably early next month. So, well, I want to say thank you to everybody. Let me display my goodbye screen here. So you should be seeing that. So thank you. That wraps us up at just a hair over an hour. So if you have any additional questions, you're welcome to email me at EnergyCode AceTV. So you know, Lindsay, what is my email address? Give me just a second here. AceTV. It's yeah, my email address, which I'm starting to get more email address at, is ACETV at EnergyCodeAce.com. So AceTV at EnergyCodeAce.com. I'll make sure that there's a link in the description. So, all right, that's a wrap. Thank you, everybody. Appreciate you sticking in for today's episode. Look forward to next month. If you have any suggestions for our next episode, please hit me up either in the chat window or send me an email. So thank you, everybody. Have a wonderful day.